In this video, I'm going to demonstrate how to complete the square to solve a quadratic when the solution is not a rational number, but an irrational number. So let's take a look at this equation that I've got up on the screen. 2x squared minus x minus 5 equals 0. When we solve a quadratic, we're looking for the x-intercepts. And so we want the y value to equal 0. The first step for solving using completing the square is we want to isolate the x squared and the x on one side of the equal sign and put the numbers on the other side. In order to get this minus 5 to the other side, we have to add 5 to both sides. That leaves the 5, negative 5 will be gone over here, and the positive 5 will be on the right-hand side. The second step in completing the square is that we want the coefficient of the x squared to be a 1. And in order to do that, we are going to have to divide each of these terms by 2. That leaves us with an x squared for our first term. I'm going to pull this 2 out in front as a coefficient of the x, so I have 1/2 x. I'm going to leave a space here, and that equals 5/2. Now I need to find a number that I can place right in here that will allow me to have a perfect square trinomial. In order to find that middle term, we're going to take the coefficient of the linear term, that's our negative 1/2, and we're going to cut that in half. And once we've done that, then we're going to square the result. So negative 1/2 times 1/2 is a negative 1/4. And when we square that, we get a positive 1/16. This is the number that we want to place inside of our trinomial in order to make it a perfect square trinomial. If we add a number to the left side, we have to also add a number to the right-hand side. And that's that part here. Okay. So that was step 2 and step 3. Step 4 is we want to change this trinomial into a binomial. This was the whole point of completing the square, is to get to this level. You take the square root of the first term and put it in. Take the sign of the middle term, and then the square root of the last term. And this we have to combine together. So I'm going to move over here as my workspace here. And I'm going to combine 5/2 with 1/16. In order to combine these, I have to have the same denominator. So I have to think about what can I multiply numerator and denominator by. It has to be the same number in order to get a 16. So I'm going to multiply by 8 and by 8. When we multiply by 8/8, it doesn't change the value of the fraction. It just puts it into a different form. So we end up with 40/16 plus 1/16 gives us 41/16. Now when we take the square root of both sides, wrong pen, the left-hand side the squaring and the square root cancel one another, and we get x minus 1/4. And on the right-hand side, because when we take the square root, we always get a positive and a negative root, we need to take the square root of this number. The problem is that the square root of 41 is, there is no way of taking the square root of 41 without having a number that goes on forever. That's why it's called an irrational root. But the denominator we can take the square of, and the square root of 16 is 4. So this allows us to have a rational number on the bottom and the irrational number on top. And then the final step is to get x by itself, and we're going to add this 1/4 to both sides. Now, it's usually all right to leave your answer in this format, but if they're asking you specifically for the x-intercepts, you want to write it as points. So the way you would write this, first of all, you can combine these into one fraction. Since they both have the same denominators, you can also place the 1 plus or minus square root 41 in the numerator with the 4 in the denominator. And so we can bring it up here, and our solution would be 1 plus square root of 41 over 4, 0. That would be 1 point. And the other point would be 1 minus square root 41 over 4, 0. Now, if this was an application problem, these numbers written as they are don't necessarily make sense in the context of a problem, but these are the exact answers. Usually with a context of a problem, you want to change these into some sort of decimal number. So you would put the number into your calculator, and whatever decimal place makes sense for that particular problem, that's where you would round your answer to. But these are the exact answers to this quadratic equation.